Hi, good morning. With the help of this animation, let's see how a fuel injection pump works. So this is a rotor type fuel injection pump. You can see this movement over here and also the rotation of the rotor. It's a vane type pump over there. So these are the internal components. This is the top view, which consists of the throttle lever. And this is the internal side view and this is right side view. So let's see how it works in detail. Okay, so these are the views as I told, the top view of the fuel injection pump, the front view with an internal view, and this is the side view. Okay, now let's see in detail. This is the rotor pump over here. This is a vane type pump, and you can see these are the four vanes which are marked in red over here, and in between them there are springs. These vanes have been connected using springs. You can see this is the casing of the rotor pump, and it is connected towards these vanes are connected towards this particular circular object, which is a bit offset from the axis, the center of the axis of rotation of the casing. So as you can see, when the rotor pump rotates, these vanes adjust automatically when it rotates because of the spring at center. It adjusts the movement, right? And those are the injector lines. This is the head of the pump. So from these injector lines, the connection is going towards the fuel injectors, and that's the fuel in. The fuel is supplied from the fuel tank into the FIP, or the fuel injection pump, through that line. That's the head of the fuel injection pump. That's the rotor. You can see this is a side view which showing the rotor, and this is internally how it comes inside the head. Okay, and that's the metering valve. The metering valve is actually connected internally through a gallery towards the rotor. The movement of this metering valve adjusts or controls the fuel supply. That's the governor weight retainer. It actually looks like a flower. Inside it have four or five weight retainers inside that. So as it moves, this flower closes up and opens up depending on the RPM and the demand, and which push this particular blue line over here, which I'll be showing in the animation coming. So that's the plunger. This plunger is connected towards our rotor, which is connected by the drive shaft, which gets its drive from the engine, resulting in the rotor to rotate. Okay, that's the drive shaft, and it gets its drive from the engine. It is connected towards the engine side. So this is getting mounted towards the engine to get the drive for the fuel injection pump. And those are the governor arms. So as this metering valve and the governor arms move simultaneously, same way as the governor retainers move with the RPM of the fuel injection pump. So that's a throttle shaft, and that's connected actually towards the accelerator pedal through an accelerator cable. So when we push the accelerator pedal, or when we release the accelerator pedal, this accelerator cable actually controls the movement of the throttle valve, which gives a demand towards the fuel injection pump for creating the fuel flow. So let's see. So the drive shaft rotates. How it works? The fuel injection pump working has been explained now. The drive shaft rotates. You can see it result in the movement of the governor weight retainers. You can see the governor weight retainers are also rotating right now. You can also see the vane pump, or the rotor pump, is also rotating. So when the governor weight retainers rotate, that gets its drive through the drive shaft from the engine. So when the RPM increases, what happens is that slowly these governor retainers will result to move frontwards or backwards. So it is depending upon the RPM of the engine that actually creates the fuel demand. So at more RPM we need more fuel. So you can see this metering valve is also rotating, and also this particular lever, which is in blue, is also moving because this governor weight retainer is pushing it, and it is connected through this ash colored spring towards the metering valve. And metering valve has an internal gallery connected towards this green one is internal gallery, which is connected towards our rotor pump or the vane pump. So this yellow is showing the internal view of the vane pump, which is over here. So the vane pump is actually supplying the fuel as it rotates. So the drive reaches the vane pump, and the vane pump rotates and supply the fuel through this gallery, through the metering valve, and that connection is going towards the injector lines. So as this moves like this, the metering valve moves, and that gallery actually is being controlled by the demand of the RPM. So that's one thing that's controlling the demand of the fuel flow towards the injectors. And also, when the driver is controlling the accelerator pedal, the cable connected towards this throttle valve also can be moved. So when this throttle shaft, or I mean this throttle connection, which is connected towards the accelerator pedal moves, it actually moves the metering valve because it is directly linked towards this governor arm. Just have a look at that. You can see clearly over here when this throttle lever moves, the governor arm moves, and resultingly the metering valve also moves. So that metering valve movement controls the fuel supply or the gallery, and that much amount of fuel only will be supplied towards the fuel injector line. So these are the two factors which are helping the fuel flow in a fuel injectors. It gets it drive from the drive shaft, result in the vane pump to rotate, and the governor retainers move frontwards and backwards automatically according to the RPM of the engine, resulting in the governor arm to move, which is thereby controlled the metering valve and the galleries, which supplies the oil towards the injectors. That's automatically how the fuel demand is being sensed, and when manually the accelerator is being pushed, again the governor arm is controlled and the metering valve is being controlled by the driver. That demand is also taking care of this gallery which supplies the fuel through the injectors. So that's simply how a fuel injection pump works internally. So I believe you understand how a fuel injection pump works internally. Thanks for watching this video. Have a great learning experience.